Hey everyone, welcome back to the channel. In this quick video, I'm going to show you how to find the x-intercept of a linear equation. Before we get started, I'd just like to point out that we're almost up to 50 subscribers, so I would really appreciate it if you could subscribe and support the channel. Let's get into it. First of all, it helps to know what an x-intercept actually is. An x-intercept of a line is basically where that line touches or passes through the x-axis, which is this horizontal axis right here. Unlike the y-intercept, a linear equation can have as many x-intercepts as it wants, or it can have none at all. Since all values along the x-axis are at y equals 0, we can find the x-intercept by setting y equal to 0 and solving for x. This is best visualized with examples, so let's go through a few together. Let's say you have this equation where y is equal to negative 4x plus 8. We can set y equal to 0 and solve for x. So if we set y equal to 0, that term goes away and we're left with a 0. Now we can solve for x. The first thing we should do is subtract 8 from both sides of the equation. That gives us negative 8 on the left-hand side, and on the right-hand side, these two terms go away, and that leaves us with negative 4x. Next, we can divide by negative 4 on both sides, and the left-hand side turns to 2. On the right-hand side, the negative 4's cancel out, leaving us with just x. So that tells us that that point right there is at 2, 0, because our x-intercept was x equals 2. That was a pretty easy example. Let's take a look at another example. Let's say you're given this line shown on the graph, and it's represented by the equation y equals x plus 1. What would be the y-intercept? Well, we could simply plug in y equals 0 for the y, and that would give us 0 equals x plus 1. After that, all we would do is subtract the 1 over to the left-hand side, and that would give us x equals negative 1. That's going to be right here, which is at the coordinate negative 1, 0. Don't forget, all of these x-intercepts have a y-coordinate of 0 because all x-intercepts fall along the x-axis and at y equals 0. Let's take a look at one more example. Let's say you're asked to find the x-intercept of this equation. You might notice that there's no x term in this linear equation, but it is a function nonetheless. What would be its x-intercept? Well, if we try plugging in y equals 0, then we get 0 equals 2, which makes no sense. Let's try graphing it instead. The graph of this linear equation would look like this, where this point right here would be 2. As you can see, it's just a flat line that goes through the y-axis and it never touches the x-axis. This makes sense since our equation has no x term because the coefficient of the x term is 0. This means the graph has 0 slope and it's completely flat. This also means that the graph doesn't actually touch or cross the x-axis, and that means it has no intercept. As you can see, it's quite easy to find the x-intercept of a graph as long as you recognize that a graph may have multiple x-intercepts or have none at all. I'll make a video in the future discussing graphs that have multiple x-intercepts and multiple solutions, so stay tuned for that video. If you found this video helpful, make sure to leave a like down below. Thanks for watching.